All right, today we're going to be looking at the notes for discrete functions. Remember, discrete functions are where functions are not connected. So we normally distinguish them with dots, such as cost of tickets, month and a savings account amount, or then like the comfort customers and the number of samples. We're looking at the domain and range of discrete functions. In discrete function, a set of data is said to be discrete if the values belonging to the set are distant and separated. They are unconnected values. So when you look at the points, those points are not connected to each other. They can be counted. A lot of times in a word problems, they're preceded with the words number of, and they're written using what's called set notation. Often written with these brackets. So our discrete domain and range will be written with these brackets, and the stuff that we write will be in the middle. So domain and range of any function is always the set of possible x values, also referred to as input or independent variables. The range is always the set of possible y values or output, and also known as our dependent variables. So looking at these different examples down here, these are the different ways that we can see different data sets and domain and range of different functions. In algebra, we have ordered pairs, equations, which are going to be very common in algebra. You can see the data set as a table, as a graph, as mapping, which mapping we won't see a lot of anymore. That's more of an elementary or middle school type idea. And then, of course, verbal we'll see often as word problems. So the numbers that I use for the table above and right from are based on these down here. So our domain are x values in our ordered pairs. So our ordered pairs are down here to the bottom left. Our x values are the ones that come first. So our ordered pairs for the domain is -2, 0, 5, and 8. Our range is the y values, which is 3, -1, -7, and -2. For the table, our x values are the top numbers, our domain is the top numbers, our y values and the range is the bottom numbers, the temperature. So for the table, it's 0 to 60, 1, 0, 10, 20, 30, 40, 50, and 60. And on the y values, it's the temperatures. It starts at 200, 157, 128, 109, 99, 92, and 90. And remember, thinking back to what functions are, this is one of the best examples of how functions operate. At the start of this table, the temperature I'm guessing in an oven is 200 degrees, and they're letting the oven cool off. After 10 minutes, it's down to 157. After 60 minutes, it's down to 90. Now, thinking back to the idea of functions, it would not make any sense that at 60 minutes, it is both 90 degrees and another temperature like 157. An oven can't be two different temperatures at the same time. However, yes, at 60 minutes, it could be 90, and at 65 minutes, it might still be 90 degrees. So your range can repeat, but your domain cannot repeat. In the graph, you're looking at the different points. It's kind of difficult to see, but the points look like they're -3, -1. It does look like there's a point 0, 0 in there, 3, and 4. For your range values, I'm just going to base it off looking at the points left to right. So the first one, y value is 3. The next one is -2. We're at the point 0, 0. The next one is -4. And the last one is 4. It's important to note that your domain and range, the way that we write out these values, it doesn't matter what order you write them in as long as you can identify all of the values. I tend to write least to greatest, but you don't have to. Mapping straightforward. The ones on the left are the domain, -3, 1, 4, and 6. The ones on the right are the range, 9.5, -0.5, -8, and -13. The equation is probably the most difficult one to understand. They give you the domain. It's right here. They tell you the domain is -1, 0, and 1. In order to find the range, though, you have to plug these values into the equation to find them. So -1 in for x. -1 times 2 is -2, plus 1 is -1. My next point, 0. 0 times 2 is 0, plus 1 is 1. My last point, 1. I plug in 1 for x. I substitute it in. 1 times 2 is 2. 2 plus 1 is 3. The verbal description is talking about a game called basketball shoot. A player has 8 shots to make as many baskets as possible and receives 2 points for every basket made. The total number of points, y, is a function of the number of baskets, x. So the number of baskets you can shoot is your domain. And in this case, you may not play the game. So 0 is a viable point. So 0, and then it's your number of shots. 1, 2, 3, 4, 5, 6, 7, 8. And for the range, it's the set of points. So you may have made 0 shots, 2, 4, 6, 8, 10, 12, 14, and 16, because it's 2 points for every shot. The last thing and most important, or one of the more important things, is we should actually graph this on our table below here. There's 2 different ways that you could do this graph. These are your shots. These are the points. It's always a good idea and a good thing to keep in mind whenever you are working on any sort of assignment, to make sure that you identify the rate in which your graph is increasing. This one on the bottom, I'm just going to do by ones. Going up, I'm going to do also by ones. So when I graph this, 0, 0, I took 1 shot, I made 1 shot, I made 2 points. If I made 2 shots, it'd be 4 points. If I made 3 shots, it'd be 6 points. 4 shots is 8 points, and 5 shots is 10 points. Don't connect the lines. This is a discrete function. So don't connect these dots and make a line. It's discrete, so they should be separated. If you counted these by 2 instead of by 1 like I did, your graph would go this direction and be evened out. But again, they should just be dots. And that's looking at the domain and range of discrete functions.